So this is question 16 from the 2020 Advanced Maths HSC. Now this is one of our first questions involving derivatives. So, and this is quite a high mark question. This is 4 marks, and there's quite a bit of derivatives going on here. So we're given a cubic function. We're told to sketch the graph of the curve. So the curve in question is y equals minus x cubed plus 3x squared minus 1. We are to label the stationary points and the point of inflection. And we're told not to determine the x-intercepts of the curve. If you're told not to do something, don't do it, because it's probably going to be quite complicated and it's going to waste a lot of time. You get no marks for it. So the question tells us to label the stationary points and points of inflection. So it makes sense that we're going to find them first. You already know, however, what this curve looks like approximately. It's a negative cubic, right? A negative cubic looks either like that or like that. So you know it looks, the shape is one of these two because it's a negative cubic, and that's just what pretty much all negative cubics look like. But in order to find the specific curvature of the shape, we can actually use the stationary points and the point of inflection. So we'll do stationary points first. So in order to find our stat points occur when the first derivative is equal to 0. So given that our function is this, our first derivative, y prime, is going to be minus 3x squared plus 6x, and the condition is that this has to be equal to 0. So this gives us minus 3x squared plus 6x is equal to 0. We can factorize this. We can factor minus 3x out the front. We will get x minus 2 equals 0. This gives us two solutions, when this one is equal to 0 and when this one is equal to 0. So minus 3x equals 0 when x is 0, and x minus 2 equals 0 when x is 2. So these are the x coordinates of the stat points, of the stationary points. Now, because we don't just need the x coordinates, we need the x coordinates and the y coordinates. So we actually have to plug these back into the original cubic function to find the y values. So when x is 0, y is minus 0 cubed plus 3 times 0 squared minus 1. So this means y will be minus 1 when x is 0. And when x is 2, y is equal to the negative of 2 cubed plus 3 times 2 squared minus 1. Well, 2 squared is 4, 4 times 3 is 12, so this is 12. 2 cubed is 8, so this is minus 8 plus 12 minus 1. Minus 8 plus 12 is 4, 4 minus 1 is 3. So here we're going to have y is equal to plus 3. So we found our two stat points. This tells us that the stat points, stationary points, are at 0, minus 1, and 2, 3. So this is the first part of the question. The stat points, in this case, these are the mins and maxes. So one of them will be, they're not the global mins and maxes, one will be a local min, one will be a local max. And because we do have a local min and a local max in this case, we know that the negative cubic has to look like this, because this will be one of the local maxes, local max, and this will be the local min. Now if you want, you could at this stage draw a graph, draw the stat points, draw the cubic through it. You don't need to at this point, because we also want the stationary point, right? So we're going to do the stationary point first, then we're going to use we're going to do the point of inflection as well, sorry, the point of inflection in addition to the stationary points. Then we'll use the stationary points and the point of inflection to produce a very accurate graph, or a graph that is, reasonably accurate at least. So if we want to find inflection, the point of inflection is going to occur when the second derivative is equal to 0. So stationary points occurred when the first derivative was equal to 0. The inflection will occur when the second derivative is equal to 0. So given that, so here we'll have when y double prime is equal to 0, this is our condition. Y prime we calculated was minus 3x squared plus 6x. So this means y double prime is going to be minus 6x plus 6. We have to set this equal to 0. Minus 6x from both sides. We get 6x, add 6x to both sides, add 6x to both sides. 6x equals 6, divide both sides by 6. This gives us x equals 1. So x equals 1 is the x coordinate of the point of inflection. Now we also need to find the y coordinate. We do that by plugging x equals 1 back into the original cubic. So y equals minus the negative of 1 cubed plus 3 times 1 squared minus 1. The negative of 1 cubed is negative 1. 3 times 1 squared is plus 3 minus 1. This is 1. So in fact, x is equal to 1. Y is also equal to 1. So we found stat points were 0, minus 1, and 3, 2. And inflection point, it's just 1 point in this case, occurs at 1, 1. So now with our stat points and with our inflection points, we can draw a grid and we can fill these points in, draw the curve through it, because we know that it has to look like this. So long as we draw the local max and the local min, which are the two stationary points, and then the inflection point, which is the point where the curve turns around, that's going to be the one essentially in the middle. This is the inflection. We'll get a really good graph, or a reasonably accurate graph. So now we're going to draw our graph. So we'll draw a fairly big graph. We'll try and scale it correctly. It's better to scale these correctly if you can. So we have several points here. 0, minus 1, 2, 3, 1, 1. So we might go to 4 on each axis. 1, 2, 3, 4, 1, 2, 3, 4, 3, 4, minus 1, minus 2, minus 3, minus 4. So it's not a bad idea to fill all of these in. Makes your graph look a little bit better. So 1, minus 2, minus 3, minus 4. Inflection point is at 1, 1. So our inflection point is here. And then our stationary points are at 0, minus 1. So that means x is 0, y is minus 1. That's here. This is going to be our minimum. As it turns out, it's going to be a local minimum. And then the other one is at 2, 3. That's going to be here. This is going to be a local maximum. Now, we know it's a negative cubic, so it has to go down on this side, and it has to come down on this side, and then it has to smoothly curve between these, passing through the inflection point, and this is our graph. So you'll notice this graph does not have the x-intercepts labeled. We have not been asked to calculate the x-intercepts. You can sort of roughly see what they are. They're going to be something like minus 1 or minus 3/4, and the other one will be 2.9 or 3 or 3.1 or something like that. Finding them would be rather challenging, and it would essentially be a waste of time because you get no marks for them. Because you know what a negative cubic looks like, this method works really well of just finding the two stationary points, the point of inflection, and understanding the general curvature. So this is a pretty good hand-drawn graph. Your graphs do not need to be completely computer level precise, right? That's not what this is about. The exam is trying to test how well you're able to approximately produce a graph so that you can understand, what graphs look like, right? What is a computer output giving you to tell if computer outputs are wrong, for example. Sometimes computers graph things incorrectly. If you have some knowledge of what a graph should look like innately, you're less likely to fall for bad computer graphing, and it just means you know a little bit more about how functions work. So the marking scheme here is pretty straightforward. The derivative or equivalent merit, the first one, is going to get you 1 mark. So if you identify that stationary points will occur at the first derivative, something along these lines will get you 1 mark. Finding the stationary points with x and y coordinates is likely to get you the 2nd mark. Finding the point of inflection is likely to get you the 3rd mark. So if you have the stationary points and the point of inflection, that's going to be 3 marks, and sufficient working in order to prove them. You can't just say, oh, I think it's this and write it down. You actually have to use calculus, use algebra, solve, show that this is the answer, right? They want to see proof that you understand how to do this, not just the answer. Once you've got all of this, the last part of the question is just putting it into a diagram. Right? The diagram, again, does not have to be perfect. It has to be reasonably neat. But if you have found the stationary points, if you found the point of inflection, you've jotted them down, you know that this is a negative cubic, so you know the approximate shape, this is fairly easy to do.